In this video, I want to take a look at using StatCrunch to calculate a couple different types of confidence intervals. Okay, so let's recall the concept real quick about what we mean by a confidence interval. So typically the idea would be, let's say we want to build a 90% confidence interval. So what we're looking for is, here is the mean of our distribution, and we want to find the values of z that would encompass, let's say, 90% of the data around the mean. Or if we want the 95% confidence interval, we're looking for the z-scores above and below. And keep in mind, this is some metric. So if my z-score is 1.96, then I have a negative 1.96 as my critical values that would encompass 95% of the data around the mean. So that is what we're looking for, and we want to build those intervals. And typically we have an actual value of a mean, and we're finding the data values above and below the mean to build the interval in that case. So in this particular problem, we're being asked to find the z-score that would correspond to a confidence level of 93%. Now if I go back to my standard normal table here, so this is my standard normal table from a textbook, or you can find these online, and it gives me common confidence levels. So I get an 80% confidence level, that's 1.28 standard deviations above and below the mean, 90%, and here's the corresponding z-scores. The critical z values is what they're typically called. Now this problem here is 93%, so I don't have that value in my table. So the way that I'm going to look that up is I'm going to come into StatCrunch. I'm going to go to Stat, to my calculator Stat, and down to Normal. So in this case, I want 93% between two z-scores. So I'm going to choose the between option. I'm going to leave these blank because I'm looking for a z-score, mean, and standard deviation should be 0 and 1, and I wanted 93% confidence. So when I compute, there's my positive and negative z-score for my critical value. Alright, now this is a cool problem to look at here. Excuse me, where I have, in essence, a data set that I would be given. And they haven't told me what the data set is, but they have told me the mean of the data set is 58.1. So I have a sample, and my sample mean x bar is 58.81 in all four of these confidence intervals. Now, they wanted me to order these from smallest to largest, right? So I have a confidence level of 85%, then 88, then 95, then 99. Now, if I was looking for the z-score that corresponded to each of these, then I would use the standard normal calculator like we just showed. Now, in this case, excuse me, they're showing me the actual data values here. So the z-score for 85% is going to be not as far from the mean as it is for 99%. Right, and if I come back to my standard normal table, right, we can notice that for 80% of the data within around the mean, I'm going 1.28 standard deviations above and below. And then because I want more data around the mean, I have to go further from the mean. So in this case, I have to go 2.5 standard deviations above and below the mean. So when we come back to this problem, we can see that the 99% confidence interval has to go the furthest from the mean as compared to any of the smaller intervals. Now also remember, the whole purpose that we're doing confidence intervals is we're trying to, I'm going to say, catch the population mean in this interval. So we're taking a sample, we're finding the sample mean. We build a confidence interval of 85% is what this one would be, the smallest. And what we would do is we would say we are 85% confident that we have caught the population mean somewhere in this interval. And the population mean might be 59, population mean, might be 59.6. Population mean might actually even lie outside that interval. Right? So if we have 85% chance of catching the population mean in this interval, then we have a 15% chance that it lies outside the interval. So if we want a greater chance of catching the population mean, obviously we're going to choose the largest interval in that case. And then again, for a deeper conversation of what this is and applying it to word problems, take a look at my instructional videos. I just want to focus on StatCrunch here. So let's take a look at a word problem as an example. So in this problem it says you're given the sample mean and population standard deviation. Use the information to construct 90 and 95% confidence intervals for the population mean. So again, we're trying to catch the population mean in our interval based on our sample. So we're told that we have a sample of 36 business days. The mean closing price for a certain stock is $122.72. Assume the population standard deviation is 11.08. So the first thing we want to do is construct the 90% confidence interval. So I'm going to go into StatCrunch, and what I'm going to do in this case is I'm going to go to Stat, and I'm going to go down to ZStat, choose one sample with summary data. Now again, remember, as I discussed in the instructional videos, the reason we're using a z-statistic, the reason we're using a standard normal curve is we have to make sure that our sample meets the criteria of the central limit theorem. So the central limit theorem says that if my sample is at least 30, then my sampling distribution will be approximately normal. Or we're told that the second condition is if we know the population is normally distributed, then we know our sample distribution will be normally distributed as well. So we can see in this problem we have an n value of 36, and we know our value for sigma, our population standard deviation. So that's why when I went to StatCrunch, I brought up, let me exit that. I went to Stat, I went to ZStat, and not a T-stat. So I'm doing a ZStat, I only have one sample and have the summary information. So I have the mean and standard deviation. So the mean is 36, no, I apologize. The sample size is 36, mean is 122.72, standard deviation is 11.8. So we type that information in, and I'm going to come down here and pick confidence interval. And for this problem, what were we asked for? We first asked for 90%. So I'm going to tell it that I want a 90% confidence interval. I'm going to click, I actually like to see the visualization too. So I'm going to include the plot visually. And when I calculate, I can see here's the sample size, right? It's given me just kind of a reference of what we typed in. And here's our lower limit and upper limit that will catch 90% of the data around the mean. And then here's the visualization of that. So here's my sample mean of 122.72, right? And then my lower and upper limits, I'm going to have 119 and then 125 as the upper limit. Now we can do the same thing if we're just given the raw data set. So for the raw data set, I would click over here to open in StatCrunch. I'd open my data set in StatCrunch, and then I go back to Stat. I'm going to do a Z-stat. I have one sample. In this case, I have the actual data. So I'm going to choose with data. The data is in var1 column, and then I am told that the population standard deviation is 2.2. So go back to StatCrunch calculator, and my standard deviation is 2.2 for my population. So I'm going to do a confidence interval, and this one over here asks for 90%. So let me do 90%, and we will compute, excuse me, and we will see the lower limit of 8.1 and the upper limit of 9.9. Okay, now let's move on to talk about a t-distribution. So let's suppose that we're using a t-distribution to calculate a confidence interval. Now, if I'm doing this by hand with the table, right, I have looking for the critical value for 95% confidence and a sample size of 12. So when I look at the table, notice that the table wants the degrees of freedom. So degrees of freedom is one less than the sample size. We have a sample size of 12. I'm going to go down to a degrees of freedom of 11. And in this particular problem, we wanted the 95% confidence interval. So I would look at level of confidence. I would look at 95%. I'd go down to 11 degrees of freedom and then see 2.201 as the number of standard deviations I need to move above and below to catch 95% of the data around the mean. So if we want to do this with StatCrunch, what we're going to do is go to Stat. We're going to go to Calculator, and we're going to go to our T calculator. And really similar with the normal, what we're going to do in this case, excuse me, is we're going to find the degrees of freedom was 11 in this problem. And actually, wait, we want between. So the degrees of freedom is 11. I want to know the critical values that would correspond to, say, 95% between the around the mean, right? Well, I have a negative there. Let me erase. And there's the values we saw in the table. So again, the advantage to the t-calculator is if I have a value not on my table. So my table has some standard values like 80, 90, 95, 99. You know, if it wants 87% confidence interval, then I can find that value that isn't in that table for me. So if we have a quick question which says, you know, construct a confidence interval, here's the sample mean, here's the sample standard deviation, the sample size, and the confidence level. I'm going to go into StatCrunch and go to Stat. I'm going to go to T-Stat, one sample, and we have the summary data. So I'm going to type in the information requested. Right, so there is the information given within the problem, and then I'm going to click confidence interval, put 0.95, and then compute, and there's my upper and lower limits for that confidence interval. Now let's take a look at a word problem. So in this word problem we have a random sample of 24 people. The mean compute time to work was 32.7 minutes. Standard deviation was 7.3 minutes. So it asks us to calculate the 99% confidence interval for the population mean, and it says, what is the margin of error? Again, we can do all this stuff by hand. We can calculate the margin of error by hand. I'm just focusing on StatCrunch here. So let me pull up StatCrunch, and let's pull up our T-Stat one sample with summary calculator, and let's type in the given information. Alright, so I've typed in the given information. It wanted a 99% confidence interval. And then I chose to graph it so we can visualize part B. So here is the confidence interval. We have the lower and upper limits. And if we see visually, right, here's our sample mean of 32.7, and then our upper and lower limits, again, that we see provided here. So if we come back and look at that problem, right, there's our confidence interval, and then this is asking for the margin of error. And again, I could calculate this by hand, but I could take a look at that graph. So remember visually what the what the margin of error is for that confidence interval is the distance from the mean to the endpoint. Either endpoint, right? So this distance from the mean to the left endpoint and this distance from the mean to the right endpoint is my margin of error. So if I take my mean, and I'm just looking for that distance, come on. If I take that mean of 32.7 and I, subtract it from the upper limit. So if you look at the upper limit of 36.88, or if we round to 36.9, we subtract the mean of 32.7, and that is going to give us our margin of error that we see as the answer here is 4.2. All right, now we could have a problem where it asks us to do a confidence interval for a given set of data. Now in this particular problem, it's asking for the mean and sample standard deviation as well. So I'm going to click to open the data in StatCrunch. So here's my data in StatCrunch, and I'm going to find the sample mean and standard deviation by going to Stat. I'm going to do Summary Stat. I'm going to do Column Stat. Choose var1. It's going to find the mean and standard deviation here for me. So there's my mean, there's my standard deviation that we can see as the answers in that problem. So I type those values in. And again, the reason that I'm being asked for that information is it's expecting me to do this work by hand without a StatCrunch or other type of calculator. So what I'll do now is go to T-Stat and I'll choose one sample, and here I have the data. So I'll tell it that it's in var1. I'll tell it what confidence interval I want, and this is asking for 95%. And then I'll click compute, and there are the upper and lower limits. Now notice it gives me the mean. So if I was only being asked for the mean, I could give it there, but it's not telling me the standard deviation. So that was why I used the summary stats. Okay, so the last thing I want to talk to you about here is confidence intervals for proportions. So if I'm using StatCrunch to calculate the confidence interval of a proportion, let's take a look at a problem that would involve a proportion. So this problem says in a survey of 2,246 adults, 1,454 say they have made a New Year's resolution. Now, the reason this is a proportion is it is binomial. So you'll notice that we basically have like success and failure, if you will. So success would be they made a New Year's resolution, and failure would say they didn't make a New Year's resolution. So that's a binomial variable. We have either one or the other. We have two possible values. You'll also kind of notice something interesting in the wording here. I'm not told a sample mean, right? And I'm not told a standard deviation of any sort. So that should be a signal to me that I have something different. I have a binomial distribution here. So if I bring up StatCrunch, the way that I'm going to attack this here in StatCrunch is I'll go to Stat, and then instead of the Z-stat or the T-stat, we will choose the proportion stat. Now in this case I have one sample, and I have the summary of the information. Now, it is asking me, for the number of successes and the number of observations. So let me pull my problem back up. So the sample size is the number of observations, and then the 1454 is the success, right? The answers of there is a resolution. And then the other people would be the failure, that they don't have a resolution. All right, so again, my N and my P value, if you will, right? My number of observations, my success, and then it asked me for two different confidence levels. So let's do the 90%. I'm going to choose confidence level. I'm going to choose 90%. I'm going to leave it on the default. And then, I could do the plot, click compute. Here are my upper and lower limits for my proportion. And remember, these are like percentages in essence, right? So I had the, I had 65%. So if I take 1454 divide by 2246, that is 65% of my total. So if my proportion is 0.65, then these are the upper and lower limits that would build the interval that catches the population proportion, right? So here's my sample proportion. And then if I build my interval 95%, right, I'm 95% confidence the population proportion lies in that interval. So let's take a look at one last problem here. In this problem, they're asking for the confidence interval of a population proportion. And notice they didn't give me the summary statistics, right? They've given me basically the data set. Now usually I have that little window, that tiny little thing that looks like a window. I can click it and open in StatCrunch, and this one isn't doing that for me. So what I'm going to want to do in this scenario is type in these percentages, of course as decimals, as proportions, into StatCrunch. So I'm going to want to bring up blank page in StatCrunch and type the decimals into a column. Alright, so I've entered that data here, and then I'm going to go to Stat. I'm building a proportion stat. I have one sample, and in this case I have the data. Alright, so I'm going to tell it var1, and I need to know the number of successes. Now if I come back and look at this problem, I'm not specifically told the number of successes. I am told kind of the sample size N of my survey. And this first problem says a 99% confidence interval for the proportion of students that expect to stay at their first employer for 3 or more years. Now I know from the survey that the ones who expect to stay for 3 or more years is 71%. Now this is 71% of the 2,500. So what I would do, take out a calculator, multiply 0.71 times 2,500, and that'll tell me out of how many people I would have as a success. Alright, so I did that on my calculator and I get 1775. Alright, so in StatCrunch, I'm going to click Stat, Proportion Stat. We have one sample and we have the summary. Our number of successes we got was 1775. The problem said we had 2,500 observations. I'll do confidence interval, and for this problem that was 99%. So click compute, and we can see there are the upper and lower limits for my interval.